students, in this video we are going to discuss about types of errors in measurement. Types of errors in measurement. Types of errors in measurement. Hi students, in this video we are going to discuss about types of errors in measurement. Now go for the discussion. Here there are point number 1. It is systematic error. Actually types of errors in measurement are classified into 3 parts. One is systematic error, random error and least count error. Now I would like to explain one by one. First, systematic error. Systematic error. Systematic error. It is once again classified into 3. Point number 1, instrument error. Instrument error. Point number B, imperfection. Imperfection in experimental technique. Or the another name is procedure or imperfection in experimental procedure. Now point number C, personal error. My dear students, once again I am repeating, systematic error once again classified into 3 subparts. One is instrument error, imperfection in experimental technique. The another name is imperfection in experimental procedure. Point number 3, personal error. Next, point number 2, random error. Third one, least count error. Least count error. Once again, like that, there are 3 types of the error in measurements or 3 types of the errors. One is systematic error, second one is random error, third one is least count error. So once again, the first systematic error classified into 3 parts: instrument error, imperfection in experimental technique, or imperfection in experimental procedure, or personal error. Now I would like to explain one by one in brief. The first one is systematic error. Systematic error. The first one is systematic error. What is systematic error? The systematic error are the systematic errors the systematic errors are those errors those errors that tends to that tends that tends to be in one direction in one direction either positive either positive or negative. Once again I am repeating, the systematic errors are those errors that tends to be in one direction, either positive or negative direction. So such errors we can call as systematic errors. Okay, now here once again I told three types are there. What are that? Point number 1, instrumental error. Instrumental error. Instrumental errors. Now go for the discussion. What is instrumental errors? This is erases this is erases due to imperfect design or calibration. Calibration of the measuring instrument. Comma, zero error in the instrument. Zero error, zero error in the instrument. Zero error in the instrument. Once again I am repeating this point, my dear students. This is arises due to imperfect design or calibration of the measuring the instrument. Zero error in the instrument. Now I would like to give an example. Example, the temperature of a thermometer, the temperature of a thermometer may be inaccurately inadequately calibrated calibrated 104 degrees centigrade at the boiling point. At the boiling point of water. At the boiling point of water. Yet STP. Yet STP. What is STP? STP means standard temperature and pressure. Whereas it should read it should read 100 degrees centigrade. Okay, once again, the temperature of a thermometer may be inaccurately calibrated 104 degrees centigrade at the boiling point of water at STP, at standard temperature and pressure, whereas it should be read 100 degrees centigrade. Now, another example, in a vernier calipers, vernier calipers in vernier calipers, the zero mark of vernier scale may not coincide with the zero mark zero mark of the main scale. Of the main scale. That means I draw a diagram to make you understand here. Now take 1, 2, 3, 1, 2, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Now take here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is vernier scale. This is main scale. Main scale. Actually, the vernier scale, this should be coincide with 0. This is 0, 1, 2. This is 0 or 1 coincide with this first line coincide with 0. But here it is not coincide with 0 first. It is starting the coincide with the second. That means in a vernier calipers, the 0 mark, this is the 0 mark of vernier scale may not coincide with the 0 mark of the main scale. This is main scale, this is vernier scale. That means this is also called as instrumental error. Now we are going to discuss about imperfection in experimental technique or imperfection in experimental procedure or error due to imperfection. So I would like to give an example for this one. A person who got fever. Suppose his fever is 100 degrees, 100 Fahrenheit. Now we can take the thermometer, we can keep at the armpit. As a result, it shows 99 only. That is also an error. That means that error we also called as error due to imperfection. Once again I am explaining, a person who is suffering from 100 Fahrenheit. Now we took the thermometer, we kept the thermometer not inside the body, kept it his armpit. As a result, the thermometer shows 98 or 99 Fahrenheit. That indicate that such errors we called as error due to imperfection. Now go for the notes. To determine to determine the technique, the temperature, to determine the temperature to determine the temperature of a human body a thermometer placed under the armpit, placed under the armpit. Armpit will always gives a temperature will always gives a temperature lower than the actual value. The actual value of the body of the body temperature. Temperature. Since other external conditions that is change in temperature, change in temperature, humidity, change in temperature, humidity, wind velocity, during the experiment. During the experiment may systematically affect the measurement Once again I am repeating this point, my dear students. To determine the temperature of a human body, a thermometer placed under the armpit will always gives a temperature lower than the actual value of the body temperature. Since other external conditions, that is change in temperature, humidity, wind velocity during the experiment may be systematically affected the measurement. Therefore, this error we called as error due to imperfection. Now we are going to discuss about personal errors. It arises due to an individual's bias, lack of proper lack of proper setting of operator. Operators or individuals carelessness. Individual carelessness in talking, individual carelessness in taking, individual carelessness in taking observations with observations without observing proper precautions. Proper precautions. Now, once again I am repeating this point, my dear students. It is arises due to an individual bias, lack of proper setting of operators, or individuals' carelessness in taking the observations without observing proper precautions. Now, example. We always hold your hand. We always hold your head. A bit too far, to the right, while reading the position of a needle on the scale. So we will introduce an error. Due to parallax. Once again, I am repeating this point, my dear students. We always hold your head a bit too far to the right while reading the position of a needle on the scale. So, we will introduce an error due to parallax. This is one of the example. Now, I would like to give another example. Now we are going to discuss about random error. Now we are going to discuss about random error. The random error are are those those errors which occur which occur which occur irregularly irregularly and and random with random with respect to random with respect to sign and size. Sign and size. Once again, I am repeating this point. The random error are those errors which occur irregularly and random with respect to sign and size. These can arise these can arise these can arise due to random and unpredictable fluctuations. Fluctuations in experimental condition. In experimental conditions. Once again, I am repeating this point, my dear students. The random error are those errors which occur irregularly and random with respect to sign and size. These can arise due to random and unpredictable fluctuations in experimental conditions. Example, unpredictable fluctuations fluctuations in temperature, in temperature, comma, voltage supply, comma, mechanical vibrations, mechanical vibrations of experimental setup, experimental setup. Once again, I am repeating this point. Unpredictable fluctuations in temperature, voltage supply, mechanical vibrations of experimental setup. Now, when the same person repeats the same observation, the same observations same observations, he may get different readings, different readings every time, every time. The reason is these above physical quantities will be fluctuate. So such a fluctuations of errors we can call as random errors. Now the third one is least count error. I would like to explain what is least count error. The smallest value the smallest value that the smallest value that can be measured by the measuring instrument. Measuring instrument is called its least count. Its least count. Once again I am repeating this point, my dear student. The smallest value that can be measured by the measuring instrument. What is the measuring instrument? Spirometer, screw gauge, vernier calipers, or our geometrical scale, whatever it may be. Measuring instrument is called its least count. Now, the least count, the least count error, the least count error is the error associated with the resolution of the instrument. Once again, I am repeating this point. The least count error is the error associated with the resolution of the instrument. You know what is the resolution? 0.1, 0.01, 0.001, all these are resolutions. Okay, I already explained what is resolution, what is accuracy, what is precision, how the resolution is directly proportional to precision and inversely proportional to accuracy, and so on. Now, example, a vernier calipers, a vernier calipers has the least count as 0.01 centimeters. A spirometer has the least count 0.001 centimeter. So this is about least count error. So least count error which will be arises due to its resolution of the instrument. Now note, using instruments of high precision improving experimental techniques we can reduce the least count error least count error. Now repeating the experimental observations. Several times. Taking the arithmetic mean. Taking the arithmetic mean. Taking the arithmetic mean of all experimental observations experimental observations we can reduce the we can reduce the errors. Once again, I am repeating this point, my dear students. Using instruments of high precision, improving experimental techniques, we can reduce the least count error. Full stop. Now, repeating the experimental observation several times, taking the arithmetic mean of all the experimental observations, we can reduce the errors. Next, note the mean value would be very close to the true value of the measured quantity. Of the measured value or measured quantity. That is why, once again I am repeating this point, the mean value would be very close to the true value of the measured value or measured quantity. That is why in any experiment we can take minimum 5, 7, 9 readings and take their mean, because the mean value always very close to the true value. So that is why we are taking the average or mean value. Okay, in any experiment. So why we are taking mean value? This is the reason. Okay. However, my dear students, I hope you understood today discussion. What are that and how many errors we have? We have three types of the errors. What are that? Point number 1, systematic error. Point number 2, random error. Point number 3, least count error. These three errors we discussed in this video. However, thank you very much for watching this video. Thank you. So in this video we discussed three errors. Thank you very much for watching this video with full of patience.